how to develop a Zelda-like with THREE.JS. You're on the Nightcoder channel, and in this fourth tutorial, we're going to take care of the audio part. We'll be looking at how to add sound to your game as simply as possible, and always in pure JavaScript.
C'est parti!
In the last video, we saw how to animate a character with THREE.JS. Our character can move around a level and attack. Each action triggers an animation. The aim of this video is to combine sound effects with character animation. I'll also do some level design with Blender. And in the last part, we'll adapt the sound to the material where the character is moving. We're going to do all this without lib in pure JavaScript. As a reminder, the tutorial source code is available on GitHub. The aim of this tutorial is to add sound to the character. I'll start by adding the audio file addresses as character constants. When the character's class is instantiated, we initialize the character's physics, we load the visuals, we load the animations, and now we'll load the audio files. For this, we need a new component, the SoundManager. This new component will help us load and play sounds. The first step is to load the audio files. For each audio asset, we'll use the load function. We'll talk about audio assets later. This component doesn't exist. We'll have to create it. To start with, we're going to create a very simple class. We don't need any dependencies. We'll create a tracks property that will store all audios linked to the instance. We don't need a constructor. We'll just create the load method to load the audio assets. I use the native audio component that will directly load the given address. And I store each audio player in the tracks property with a key value system. The key is simply the file address. The less code and variables, the better. We're now going to code the method used to play a sound. We retrieve the sound to be played using its key. I reset the player before each startup, then we start playing. We've finished our first version of the audio manager. I return to the character. At this stage, the character instance loads animations and sounds. Now, how do I play sounds based on the character's actions? We could do scripted code with conditions and tempo, but that would quickly become unreadable. That's what I did when I coded the game before doing the tutorial. I went fast without thinking too much about it. If you look at the source code, trust the tutorial and not the game code. For the tutorial, I'm going to take a more subtle approach. We're going to synchronize the sounds to the animation life cycles. For each animation, we have a beginning, a middle, and an end, or a loop. We'll hook up to the animations to trigger functions. Currently, for each controller action, we start an animation, and we'll listen for animation events to trigger sounds. For the attack animation, halfway through the animation, we'll play the yell sound. For the run animation, at the end of each loop, we play a footstep sound, and halfway through we play another footstep sound. By the way, you can easily add other behaviors to the character. I've loaded some new animations and sounds. As soon as you press the lock key, you start the shield animation. And as soon as the animation starts, the shield sound plays. The code is concise and we've completed the functional logic. But we have a problem. The animation manager doesn't know how to do that. We'll have to implement it. We'll modify the animation manager. We'll store the functions to be triggered in a new map property. The animation names will be used as keys and the functions to be triggered as values. For each animation, we add the storage variable. And I'm going to start coding the function that will link animation and sound. As parameters, we have the name of the animation, the event, and the function to be triggered. We use the animation name to retrieve the storage variable. And we add the function with the event name as the storage key. Only one function per event. To trigger the functions, call the FileListener method with the name of the animation and the event. We retrieve the variable where the functions are stored. And if a function associated with the event exists, we trigger it. That's fine. Now it gets complicated. How do we go about triggering events based on animations? As a reminder, with THREE.JS, it's the mixer that launches animations. It's the mixer that manages the animation process. We're in luck, THREE.JS has anticipated this need. the animation mixer lets you attach functions to animation events, exactly as with native JS. You specify the event, then the function to be triggered. Each time the mixer detects the end of an animation loop, the function is triggered. Specify the animation name and event. Fire Listener will automatically launch the linked function. Every time the mixer passes the middle of an animation, we do exactly the same thing. For the animation start event, there's no need to attach to the animation mixer. We'll simply trigger Fire Listener when an animation is called. At this stage, we're done. We can now launch the game. But no, there's still one little detail to sort out. Those who know THREE.JS will have seen it. The half event doesn't exist in THREE.JS. We'll need to modify THREE.JS to suit our needs. To do this, I'll add a modification script. Just a word of advice. When you have a specific need, instead of coding a gas factory, it's better to slightly modify the lib source code. For a game, there's little risk. The animation lifecycle is managed by the animation action class. And here we have a problem. Animation action is not one of the dependencies available in THREE.JS. This is a class that is part of the inner workings of THREE.JS. I'll have to cheat. I need to access the animation action class. To do this, I instantiate a mesh. I instantiate a mixer. I create an empty animation clip. And I associate the clip with the mesh via the mixer. The result is an animation. You can start or stop it. This modifies the function that manages the animation lifecycle. This method is update time. To modify this method globally, we'll access the animation action class directly using its constructor. All we have to do now is dig into the THREE.JS source code to retrieve this function. I make a copy of the method and paste it into the project. You can see the event dispatcher, repeating an animation loop, end of a repetition, end of an animation, and I'll add my new event here. As soon as we get halfway through the animation and the event hasn't been triggered yet, then I'll trigger it. And I add the new operating property to the class. Everything's okay, we're done. Now our animation handler supports the loop, half, and start events. Depending on actions on the controller, we trigger animations on the character, and depending on the status of the animations, we trigger sounds. Testing. We have a sound for moving, for attack, for shielding. Before I start creating a real level, I'm going to improve the audio system. Instead of having one sound for each animation, we'll use several versions of the sound. The more variability, the more credible the sound. I'll code this quickly and we'll move on. We'll pass the address of each audio asset into several distinct addresses. Instead of having one sound per key, we'll have an array of sounds. For each address, we create an audio instance, and we've linked each array to the key used. This is invisible to the user. For playing, we retrieve the sound array associated with the key and select a random audio instance. Then start to play. We're done. By the way, I've added the parsing function to the toolbox. I'll skip the details. We are no longer on a THREE.JS tutorial. The function returns an array of paths to audio resources. Let's test it. We've got sound variability. For the tutorial, I have very little variability. I just wanted to talk about this subject, which I think is important. For the rest of the tutorial, I've expanded the level. I created several construction assets and assembled them, and merged the geometries to optimize performance. I've covered this in another video. The fewer instructions per frame, the smoother the game will be. The level design is complete. We have two types of geometry, visual geometries, colliders, and I'm going to add a third type of geometry. I will add AAB boxes with a naming convention. Area, type. Each box indicates the material where the player is moving. There are dirt, wood and stone surfaces. The default is grass. I export in GLB format. Back to the code. I'm going to modify the level loader. the file meshes are divided into two arrays: visual meshes, collider meshes, and now the area meshes. To discriminate, I use the same method. We simply test the meshes names. And the loader returns the three asset categories. The game will use the new scene. I add a new variable to class world. As soon as the class is instantiated, we'll initialize this variable. For each area, we create an AB box component. I avoid adding complexity to the class. I'll create a dedicated class. This class will inherit the box component from THREE.JS. During construction, the surface type is retrieved using the naming convention. Then, we copy the data from the geometry collision box. To check whether the player is in the box area, we create the in function with an absolute position as parameter. We'll use box3contains_point method, which tests for collision with a coordinate. If a collision occurs, the type is returned. If there is no collision, we return null. Back to the main code. It's not up to the world instance to change the character's state, but up to the character to change its internal state. At each frame, the character will use the game's data to update itself. Every frame, the character will search for the kind of ground he's moving on. I add a new property. The ground update function. By default, we're on grass. I'll test each level area. If there's a collision, I'll update the ground and quit. Let's do a quick test with the console. I go to the dot is detected. I go to the wood is detected. All that remains is to modify the sound according to the ground property. I'm not going to do it that way. Once again, we're going to avoid coding conditional functions. We'll create a new constant with a key value system. When you have the grass key, you have the grass audio key. When you have the wood key, you have the wood audio key. Same for dirt, same for stone. All we have to do is use this constant with the ground property. It's very easy to read and saves more than a dozen lines. We're done. The sound changes according to the ground. It's okay for the physics engine. Okay for the animations. Sound okay. All that's left is to add mobs and items. To sum up, the character code remains simple. At startup, the physics are initialized. Visual assets, usable animations, usable sounds. Sounds and animations are synchronized. In the next video, I thought I'd talk about creating mobs or collectibles. This would be a good opportunity to talk about inheritance, but to be transparent, the concept of an iterative tutorial doesn't work, and it's a lot of work. Those of you who follow me know that I'm very busy with my novel studio project, and YouTube is slowing me down a lot. If the video works, I'll continue with the THREE.JS tutorials. But if not, I'll be moving on to a new, much less time-consuming concept. As usual, if you have any questions, please don't hesitate. Don't forget to like and above all, to subscribe. That was Codeur de Nuit. See you next time.